Hello everybody, this is lesson 5.5, solving polynomial functions. Alright, so we're going to talk about how to solve polynomial functions by factoring. So there are many different ways to do this, and just depending on what kind of polynomial you have, that determines what kind of factoring technique you want to use. So for example, the very first thing you want to do is actually try to find the greatest common factor. If there's any greatest common factor to pull out, do that first. Okay. Next, if you see that you have a binomial, meaning you have two terms in your polynomial, you want to use one of these strategies. You want to use either difference of two squares, sum of two cubes, or difference of two cubes, just depending on what kind of polynomial you have. All right, but if there are two terms, these are the three different ways you can factor it. If you have three terms, then you can either have a perfect square trinomial, and you can factor it that way, or you can just factor it like you guys normally do. All right, and if you have four terms, then you want to use grouping. So you want to factor by grouping if you have four terms. All right, so let's go ahead and look at some examples. So number one, it says, factor completely if the polynomial is not factorable, right prime. All right, so it is possible for polynomials not to be factorable. All right, so for number one, I noticed that I do have a greatest common factor that I can pull out. So first, I am going to pull out a 14, and I can also pull out an x and a y square. All right, and after that, I am left with x in my first term, and I'm left with 3y in my second term. Now, looking inside the parentheses, I see that I cannot use any of my binomial factoring strategies. It's not a difference of perfect squares, it's not a sum or difference of two cubes, so this is going to be my final answer. All right. It's not asking us to solve yet, so that's why that is my final answer. I don't have an actual solution for x. I'm just asked to factor. Okay, let's try number two. All right, number two, I noticed that all four terms, there isn't a common factor, so I can't use GCF. And then I count how many terms there are, and I see that there are four terms. So I'm going to go ahead and try to factor by grouping. All right, so by grouping, I notice that my first two terms, I can pull out a 6m, and I get n plus 3 left. And in my second pair, if I take out a minus 1, I'm left with n minus 3. Ooh, plus 3, excuse me. And I caught that because I need these two to be exactly the same. All right, so now, since these two terms have the common factor of n plus 3, I can pull out the n plus 3, and I'm left with 6m minus 1. All right, and that is my final answer. I always double check and make sure that I can't continue to factor. Both of these are not factorable, so that is my final answer. Okay, and number three, I would go ahead and notice that there is a GCF there. So I'm going to pull out a 2 first, and I have an x squared plus 9x, and squeezing in that 8 right there. And inside the parentheses, I have a trinomial, so I can go ahead and factor that to be x plus 1 times x plus 8. And that is my final answer. All right, do make sure you do bring down that 2. That 2 is part of your answer. Okay, so once you're ready, go ahead and practice that with numbers 4 through 9, and then check back here once you're ready. All right, so if you're ready, here are the answers. Starting with number 4, the answer is x squared plus 1 times x plus 1 times x minus 1. Number 5, our answer is 5x cubed y times 7y cubed minus 12x. And actually you can write it as 5x cubed y times negative 12x plus 7y cubed if you want to write it in order. Either way is fine. All right, number 6, we have our answer, which is 2 times r plus 5 times r squared minus 5r plus 25. So that was using the sum of 2 cubes on that one. All right, and number 7, answer was 10m to the 4th plus 3 times 10m to the 4th minus 3. Number 8 is prime. And 9 is c times c plus 1 squared times c minus 1.